Hello everyone. In this lecture, I shall discuss the Bernoulli's differential equation. Recalling the previous lecture, where we have discussed the linear differential equation. The linear differential equation takes the form dy by dx plus pxy is equal to qx. Here y is the dependent variable. Now it is linear in the dependent variable y. Right? It is the general form, and here you should ensure that the differential equation must be of degree 1. There should not be the product of dependent variable and oblique or the derivative terms. Likewise, there should not be no transcendental function of y and oblique or its derivatives. So then this is a linear differential equation, and however the general form is like this. Now coming to the Bernoulli's differential equation, the differential equation takes this form. Right? There is some y to the power n is multiplied here, and n is not equal to 1. You see, n is not equal to 1. If n is equal to 1, then it will return to this. So n is not equal to 1. Then it is a Bernoulli's differential equation. Okay. Now our job is we want to reduce it to linear. Our objective is we want to reduce it to linear. Reduce it to linear. How to reduce? Reduce it to linear. Okay. So how to reduce it, we will see. Before that, let me to introduce myself. Myself, Professor Susanta Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, Burla, Odisha, India. Now, without much delay, let me to tell you how we will reduce it to linear form. So now we first divide this y to the power n throughout. If we divide this y to the power n, we divide it throughout. So then it will be my y to the power minus n plus pxy into y to the power 1 minus n is equal to here q of x. Okay. So next we just substitute y to the power 1 minus n is some other variable t. Okay. Now you substitute, put y to the power 1 minus n is equal to t. So what does it mean? If you differentiate it, 1 minus n y to the power minus n dy by dx is dt by dx. Okay, is dt by dx. So this implies y to the power minus n dy by dx is 1 by 1 minus n dt by dx. So now you substitute this thing dt by dx. Here dy by dx is here, dy by dx is here. So now you substitute this y to the power minus n dy by dx, this, replace this. So this implies we will get 1 by 1 minus n dt by dx plus pxt is equal to here qx. You may now multiply 1 minus n. So dt by dx plus 1 minus n px. 1 minus n is a constant. Okay, pxt is equal to 1 minus n here qx. Okay, if I write it, it is dt by dx, and I write it this as small p plus on small pxt is equal to, I write it some small qx. Now you see, is it not here linear? Okay, which is linear in t now. Okay, which is linear in t. So now coming back to the solution of the linear, we know the solution of the linear. Then integrating factor is e to the power integral px dx. Okay, then t into integrating factor is equal to integral qx into integrating factor dx. Okay, then we simplify it, we go on simplify it. Finally, in place of t, we will replace here y to the power 1 minus n. Finally, you replace t by y to the power 1 minus n, and whatever you get is, you get a function of xy is equal to some c. Okay, so this is your final answer. Now the thing is that this was not linear, exactly it was not linear, but we bring it back to linear. Okay, we bring it back to linear. So then after we bring it back to linear, we know the solution technique, we know, right? So this is the solution technique. So let us solve some examples. Now let us solve the following examples. Okay, Question number 1, y dash plus xy is x into y to the power minus 1. So now you see this is not linear because of this. So you first divide it. Let it be my equation 1. Divide y to the power minus 1 both sides. Divide y to the power minus 1 to both sides. Both sides of equation 1. We get it is y into y dash plus x y square is equal to x. Now you have to substitute this as t as we discussed in the procedure. Now we put y square is equal to your t. Okay, so that means 2y dy by dx, 2y dy by dx is dt by dx, but here we have y dy by dx, so that means here y into y dash is half dt by dx, so you substitute it here. Okay, so that means here half dt by dx plus x, now this is my t, is equal to your x. Now you multiply 2 throughout. Okay, so that means dt by dx plus 2x t is equal to 2x. Now you see, is it not of the form of a linear differential equation, which is of the form dt by dx plus pxt is equal to qx. So which is linear in t, which is linear in dependent variable t. So now you know the usual technique. So what is our integrating factor? Integrating factor, we have integrating factor is e to the power integral px dx is e to the power integral 2x dx is e to the power x square. Okay, so this is my integrating factor. Now I multiply the integrating factor, so this is my 2. Right, now the general solution is, thus the general solution is t into integrating factor is integral qx into integrating factor dx plus some c1. So this implies here t into e to the power x square is qx is your 2x, integral 2x into e to the power x square dx plus c1. Now you see, if I put this is equal to some t or some z, then this is my dz, is not it? This will be my dz. So it is of the form e to the power z dz. The integral is e to the power z. So I directly write it. It is e to the power z means x square plus there is some constant c2 and c1 plus c2 is my c. Okay, now I just divide it here. Okay, so that means my t is equal to 1 plus c e to the power minus x square. Right, so now I substitute the value of t. What is my t? Earlier we have taken here t is equal to your y square, so this implies my y square is equal to 1 plus c e to the power minus x square. Okay, so this is my, which is the desired solution. Now coming to your example 2, here y dash plus y by x is y square by x log y. So y to the power n is this. Because of this it is Bernoulli, not linear. So we put y square is equal to, first you divide it. Okay, first you divide it. So that means y to the power minus 2. Okay, this is y dash or dy by dx plus it is 1 by x y to the power minus 1, and this is equal to 1 by x log x. So now you put y to the power minus 1 is equal to t. So that means the derivative of this is minus y to the power minus 2 dy by dx is equal to dt by dx. Now you substitute this here. Okay, and this, there is a minus sign here, so you have a minus sign here. Okay, so that means here minus of dt by dx plus 1 by x t is equal to 1 by x log x. Just I remove this minus sign here. So that means here dt by dx plus minus 1 by x t is equal to minus of 1 by x log x. Now you see this is your linear in which is linear in t. Then you know the usual process. Then your integrating factor is e to the power integral of minus 1 by x dx. E to the power minus of ln x is e to the power ln x to the power minus 1. So this and this reverse of each other is 1 by x to the power minus 1, or is your 1 by x. Okay, so therefore your integrating factor is 1 by x. So rest you should continue. Okay, rest you should continue. Here general solution. The general solution of 2 means is 1 is given by t into 1 by x is integral minus 1 by x into 1 by x log x dx. You should integrate it. So this is equal to minus of x to the power minus 2 log x dx. Now you apply by parts. Okay, you apply the by parts of integration. So this is your first function and this is your second function, and you apply by parts. Okay, and you continue to get the answer. So let me to solve the third example. Okay, let me to finish it. So this is your minus of first integral second log x into integral of x to the power minus 2 dx minus integral of d of log x into integral of x to the power minus 2 dx whole dx. Okay, so now I just integrate it. So this is your minus of log x. So integral of x to the power minus 2 is here 1 by x minus of derivative of 1 by x is minus 1 by x square. So integral of 1 by x square, integral of 1 by x square is minus 1 by x, is not it? So you have here minus of 1 by x. Accordingly you have here we have integral of log x is minus of 1 by x, and here into minus of 1 by x dx. Okay, so this is equal to log x by x minus plus minus, it is minus of integral of 1 by x square dx. Okay, so this is equal to log x by x, and it is minus of x to the power minus 2 plus 1 by minus 2 plus 1 plus some c. So this implies here t by x is equal to here log x by x, it is minus plus 1 by x plus c. So now you multiply x throughout. So this implies here t is equal to log x plus cx. Now you substitute the value of t. The value of t is what? T is here y to the power minus 1, is not it? So that means here 1 by y is log x plus cx. This is 1. So this implies here y is equal to 1 by log x plus cx. So this is your answer. Now coming to your example 3. Now coming to the solution of this 3. This is not linear because of this y. Again by principle we should divide it, bring 1 the coefficient here. So now you divide this x into y throughout. Okay, dividing xy to both sides. We get 1 by y dy by dx plus 1 by x log y is equal to e to the power x. Then by rule we have to substitute this is equal to some other variable. Put log y is equal to t. The derivative of log y is 1 by y. Again derivative of y is dy by dx is dt by dx. Now you see this is 1 by y dy by dx. Okay, so now this and this match. Okay, so this is dt by dx. So that means here dt by dx plus 1 by x t is e to the power x. So which is here linear with this is your p and this is your q. So therefore integrating factor is e to the power integral 1 by x dx is e to the power ln x. E and ln is 1. So this is integrating factor is x. So your integrating factor is equal to your x. So therefore the general solution is, so thus here t into x is equal to integral here x into e to the power x dx plus some constant is my general solution. I solve it now. So applying by parts here, x e to the power x minus e to the power x plus some c. So that means here t is equal to, just to divide x. So just I now substitute the value of t is as here log y. So here log y. So I can write it here x log y. Okay. So this is x e to the power x minus e to the power x plus c. So I leave it. So this is my answer. Coming to example 4. Now solving this, you have bring dx to this side. Okay. So that means here x dy by dx is equal to, let it be here in this side. So it is here minus y plus y square log y ln y. So that means bringing this to this side, x dy by dx plus y is y square log y. Now you see this is not linear, because of this it is Bernoulli. Now we substitute this y square, or again I can also divide it. Okay, you divide x into y square to both sides. So that means here 1 by y square dy by dx plus 1 by x y to the power minus 1 is ln y. So what we divide here, xy square, divide xy square, okay, to both sides. So now we substitute this as another variable, put y to the power minus 1 is equal to here some t. So derivative of y to the power minus 1 is minus 1 by y square dy by dx is here dt by dx. So now you substitute this here. Okay, so this will be here dt by dx, 1 minus sign is there, I multiplied, minus plus minus 1 by x t is equal to minus of, it is your ln x. So it is your minus of ln x. Okay, so now this is linear. Okay, this is linear, and this is p and this is q. So you find the integrating factor and you continue to get the answer. Now coming to the last example. Now you see this is not linear because a transcendental function in y here. Okay, and by principle we have to bring this one. So we divide xq into sec y. Okay, so we divide xq sec y, right? So what you will get, so it is cos y dy by dx plus 4 by x tan y by sec y is here sin y is here x to the power minus 3 x to the power minus 3 e to the power x. Okay, so now by principle we have to substitute this as your t. You see the principle of Bernoulli. So you put this as t, put sin y is equal to t. So derivative of this is, derivative of sin y is cos y. Again the derivative of y is dy by dx is dt by dx. So you substitute this here. Okay, substitute this here. So that means here dt by dx plus 4 by xt is xq e to the power x, now which is a linear in t, which is linear in t. Okay, so with this as my p and this x to the power minus 3 as my q. So here integrating factor is e to the power integral 4 dx by x. So this is e to the power 4 ln x. So this is e to the power ln x to the power 4, e and ln is 1. So this is x to the power 4. So therefore here integrating factor is x to the power 4. Now you multiply both sides. Now you find the general solution. So the general solution is here t into x to the power 4 is integral right hand side x to the power minus 3 into e to the power x into x to the power 4 dx. Okay, so now so this is equal to x e to the power x dx. Just apply by parts here. So applying by parts, it is x e to the power x minus it is 1 into e to the power x plus some c. So now this implies here t is equal to 1 by x fourth x e to the power x minus e to the power x plus c. Now the value of t we substitute. The value of t is sin y. So this implies my sin y is equal to 1 by x fourth, x e to the power x minus e to the power x plus. So this is your answer. Now coming to some assignment problem. Hence to conclude, if a differential equation is not linear, then we know how to bring it linear just by divide it, and by usual principle find the integrating factor, and usual solution y into integrating factor is integral qx into integrating factor dx plus c, as usual, the general process. Now coming to some assignment problems, you should solve these 4 assignment problems to IVP and to usual. So now coming to my upcoming lecture. So before that, my appeal to all of you, if this lecture is useful and interesting to you, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. Okay. So in my upcoming lecture, I should discuss the application of applications problems. Okay. The Newton's law of cooling, radioactive decay, growth, and your electric circuit, etc. Okay. So with this, we should conclude the lecture here. Thank you all. Have a nice day.